Okay, so 3.2, we are talking about polynomial functions and their graphs. And then by the end of today, you are going to be able to describe the end behavior of a polynomial functions with and without a graph. And I think you'll actually like doing it without the graph, if you can believe it. And then you're going to determine the local maxima and minima on a graph. Okay, so we are going to be using our graphing calculators just for a little bit. Remember, you do have a quiz coming up. It's not next week actually. It's the week after. And remember, there is going to be no calculator portion on that. So the first thing we're going to talk about today is end behavior. So judging by your Chapter 3 preview packet, some of you already have end behavior down. Others of us are going to need a little refresher. Okay, and we're going to be doing this without the graph. Okay, are you guys all set with the objectives? I can put this away. Okay. All right, so end behavior. It says X, and this arrow means goes to. So we would say this X goes to positive infinity, or sometimes you'll just see infinity. You won't see the positive. That means X becomes large in the positive direction. And then negative infinity means X becomes large in the negative direction. And I really want you to think of this, I really want you to think of this as your grid, right? So when you have your grid, this is your X, this would be your Y or your output. And then on the right side, this is where X goes to positive infinity, correct? That would be on the right. If it kept increasing, it would be going to positive infinity. If it was on the left, it would be going to negative infinity. So when we're talking about X goes to positive infinity, all we're saying is the right side of the graph. That's all that means. This is the right side of your graph. As X goes to negative infinity, that just means the left side of your graph. So every graph is going to have a left and a right side. So you're always going to have X goes to positive infinity and X goes to negative infinity. Then the other part is going to be the Y. So as it's going up is when we use positive infinity. Okay, so that would be if it's going up. And then if it's going down, that's when we use negative infinity. Okay, so just to recap, if you're talking about X, X is telling you what happens on the left of the graph and what happens on the right of the graph. Your Y or your f of X is going to be telling you whether the graph is going down or up. And with X, your left is negative infinity, your right is positive infinity. With Y, down is negative infinity and up is positive infinity. All right, so that's going to help us read this chart. So notice that you have a big box here, which means it's full of important information. So see how we have these little statements here? Y goes to infinity as X goes to infinity. So remember, X means right or left. If it's going to infinity, is it right or left? Right. Okay, Y means up or down. So if it's going to positive infinity, it's going up. So all this is saying in mathematical language is the graph goes up on the right side. Okay? For this, it's negative infinity and negative infinity. So this means the graph goes down on the left side. And then you could do that with all of these. It says Y goes to positive, so that would be up. This is negative, and that's on the left. So on the left side of the graph, it's going up. This would be on on the right side of the graph, it's going down. And we just use our infinities and our negative infinities to communicate that.
Instead of y, sometimes do you see like f of x?
Yes.
Because last year that's what.
Yep, it will. And this year it'll be the same thing. So whatever your function is called, that's what you'll use. So today our functions are called p of x, so we're actually going to substitute in p of x. All right, now I want you to take a minute and I want you to notice that there are a couple patterns here. So the first thing I want you to look at is how this is classified. See how it says p has an odd degree, and that's for these two graphs, and then p has an even degree, that's for these two graphs. And I want you to tell the person next to you what you notice about those two. Let's see what you guys noticed. Michaela, what did you and Mitchell talk about?
If it's odd, one side will go down and the other will go up.
Okay, good. So if it's odd, did you guys notice that one side of the graph went up and the other one went down? Okay, and what about the even, Michaela?
They will both go up or they will both go down.
Right, okay, so what we can say is if the degree is odd, and we actually might want to just refresh and make sure everybody knows how to find the degree as well. We'll do that in a second. So if the degree is odd, we can say that the ends go in opposite directions. So I remember that because they both start with O. Okay, so odd, opposite. So if it's odd, they're going to go in opposite directions. How do you know what the degree is? Yeah, Dennis? The what exponent? Yes, the highest one. Okay, so to find the degree, your degree is the highest exponent. So I'll just make a notation of that here. And when you're reading the informational boxes, you can see it says the polynomial p of x, and then we have all of these variables here. All this is saying is x to the n, where n could be any degree. So like if n was 5, this would be 5 minus 1, 5 minus 2, because 5 minus 1 would be 4, so 5, 4, 3, 2. Yep, and then a sub 0 is going to be your constant. So I know that looks a little funny because you haven't seen it before, but that's what it means. Okay, so then if it has an even degree, if your degree is even, then we can say that the ends go in the same direction. Okay, so if the degree is even, the ends are going to go in the same direction. So now what I want you to do is there is a little bit more information that we haven't talked about in that box. And there are little statements written underneath each graph. Okay, I want you to read those little statements and see if you can find one more pattern. Perfect. So when you are looking at the negative coefficient, so these are the two graphs I highlighted, they both have negatives. What I really liked about Charlie's answer is he specified which side they're both going down on. See, both of these are going down on what side of the graph? On the right side. The left side, this one's going down, but this one's going up. So that's not going to happen every time. But then if you look at the positives, again, the right sides are the only sides that match, right? So it's going up on the right side here, it's going up on the right side there. So let's go ahead and organize this information. So the leading coefficient, or sometimes I'll just call it LCO. This will be leading co. Okay, if it is positive, we can say that it rises on the right, okay, or goes up on the right. If it is negative, it is going to fall on the right. Okay, so basically what we just did is we've annotated that entire box, right? So you don't have to go through and decipher. You have all the information here that you can use. Alright, so then let's look at example 1. Example 1, we're going to determine the end behavior of function p. So all of these are going to be p of x, p for polynomial. And then because that is p of x, we're going to go ahead and change this. Instead of y, we're going to have p of x. So instead of y, we're going to make that p of x. Now, step 1 is says graph the equation on your calculator. We're actually not going to do that for step 1. Okay, if you already did it, it's fine. But I want to show you how you can do it without it, and then you could use your graph to check. By that time, you won't even want to use your graph. So we're going to describe the end behavior. Notice that I said p of x goes to blank as x goes to negative infinity, and p of x goes to blank as x goes to positive infinity. Your x's, you're always going to have opposites. Why? What are you telling me about this? You're telling me what happens at the two ends, right? There's always going to be a right end and a left end. So you always have to make sure you tell me both. Okay? So you have to tell me what's happening on the left side, and you have to tell me what's happening on the right side. So remember, this means left, this means right. Okay? Now, whatever p of x is, those could both be up, they could both be down, it could be up and down, it could be down and up. Okay, so that's just going to depend on your graph. So for b and c, even though we don't have our polynomials yet, we already know it's going to be p of x goes to something as x goes to negative infinity, and p of x goes to something on the right side. Okay, so you're always going to have that. P of x goes to, we're going to figure that out, as x goes to the left, and p of x goes to something as x goes to the right. Now if you wanted, you could do the right first and the left second. That would be fine. So it doesn't matter if you do the left first or the right first. Alright, so let's talk about this. So the first thing I would want to do is find the leading coefficient and the degree. Okay, so the leading coefficient, Max, what is the leading coefficient for A? Okay, good. So our leading coefficient is negative. Okay, and then Max, what does that mean? If it's negative, what do we know about the graph?
That means that it's going to be going down on the right.
Yep, okay, so we know that it's going to be going down on the right. Okay, so which one of these is going to be my right side? Negative infinity or positive infinity? Positive. So I can already fill in this second one here. I know it's going to fall, so if it's going down or falling, I would have negative infinity here. Okay, so then the next thing I want to do, Cameron, what else should I find out?
The degree.
Yes, okay, so what is the degree for part A? Good. Okay, so your degree is even, so we know it's 2, and then we have to say, is that even or odd? So degree is even or odd, coefficient is positive or negative. Okay? Because is your degree ever going to be negative? No. Okay. All right, so then if it's even, Cameron, what do we know?
That, oh, it goes, the ends go in the same direction.
Yep, good. Okay, so it goes in the same direction. So that means if it fell on the right side, it's also going to fall on the left side. Okay, so it would be p of x goes to negative infinity as x goes to negative infinity, and p of x goes to negative infinity and as x goes to positive infinity. See, do you guys even want to graph it now? Nope, you don't need to, right? Okay, so you could graph it and you could see what happens. This is going to be what kind of graph? Yep. And then you'd see, oh, it's falling on this side, it's falling on this side. This is the right side of the graph of x. This is the left side of the graph of x. And then you could just state what that meant. Okay, so I'm going to give you B and C, and we will see if you can do those. Okay, so for B, you have p of x equals x cubed minus x squared minus x. And for C, you have p of x equals negative x to the 5th plus 2x to the 4th minus x. Alright, so Nick, what do I have to know about part B? Help me fill these in.
Degree and weighting coefficient.
Okay, good. So what do we know about the LCO?
It's positive.
Yep. And if it's positive, what does that mean?
The y would be negative, the p of x would be negative.
Okay, so if the leading coefficient is positive, remember we know that it rises on the right, which I know is what you told me in different words. Okay, so if this is positive, it's going to rise on the right, which means you can go ahead and you can fill in that part already. So if it rises on the right, my right side is the second one, and it would be going up. And then, Nick, how do you know that it falls on the left?
Weighting, or, degree is odd.
Yep, and what does that mean?
It has to go in two separate directions.
Yep, so if the degree is odd, it's going to go in opposite directions. So if I'm going up on the right, I have to go down on the left. Okay, and then Ryan Mays, will you tell me what you did for C? Don't tell me the answer. Tell me what you found first, okay?
The leading coefficient is negative.
Okay, good. So what did that lead you to do?
So that means when you go to positive infinity, it's
Okay, so p of x goes to negative infinity as x goes to positive. So it's going to fall on the right. Okay, keep going.
and then since the exponent is odd, it's the opposite.
Okay, so the degree is odd. So they are going to be the opposite, which means this is going to be positive. Okay, how are we feeling about that? Pretty good? starting to come back from previous years. Alright, let's flip it over then. So the next thing we're gonna do, is we are going to talk about zeros. Do you guys know another name for zeros?
What?
X-intercepts?
Yeah, zeros are x-intercepts, right? So whenever you were told to find the zeros, you're finding the x-intercepts. So that's what we're gonna do, and we're gonna do this by factoring. So we are going to factor the polynomial to find all of its real zeros, and then just keep in mind that those are the x-intercepts of your graph. Okay, and then read over example 2. And then if you want to annotate what the directions are asking us to do, that would be excellent.
Wait, is real zeros positive?
Don't you have to plug in that?
Okay, so, and yeah, the reason why I underline real zeros is because there could also be what type of zeros? Imaginary. And we
Ugh.
will work our way up to that, we just aren't doing it today. But next week we will. Okay, so, for example 2, notice that it says to factor the polynomial. So we are gonna factor the polynomial, and we're gonna use the factored form to find the zeros. So we're gonna do 2 things. We're gonna factor and we're gonna find the zeros. Well, if we're gonna factor, I thought maybe we could use a little refresher of our factoring rules. So the first step is to do what? Yeah, find the greatest common factor. So what do they have in common, if anything? Second step is look for special patterns, so difference of cubes, sum of cubes, difference of squares. And then if that doesn't work, go ahead and guess and check. Alright, so for part A, I'm going to give you your polynomial. So P of x, that's going to be x cubed minus x squared minus 6x. Alright, so the first thing we're going to do is we're going to write P of x in factored form. Okay, so let's do our first step. Do they have anything in common?
X.
Yeah, okay, so Ben, when I take out an x, will you tell me what I'm left with?
X squared minus x minus 6.
Good. And then what am I going to have to do with that?
Factor it.
Factor. Did some of you already factor it? So you're looking for 2 numbers that multiply to -6, but add a -1. Okay, Marlo, what are you thinking? It'll be, if you had 2 negatives, when you multiplied, it would be a positive. So you should have, yeah, so you need a +2. And then let's check. So -3 + 2, is that going to be -1? Yep. Okay, if you did have 2 negatives, when you added them together, what would you get? Yeah, -5. Okay, so then you know that that wouldn't work. Okay, so this is going to be your factored form. So if the directions ask you to write that, to factor it, to write it in factored form, you do have to show me that that is factored form. And then step 2, you are going to set P of x equal to 0 and solve. Okay, so what we have is x times x minus 3 times x plus 2 equals 0 now. So I know you guys know what the answers are. I just want to go over with you why it works the way it does. So you have 3 different terms that are multiplied to 0, right? If your product is 0, what do you know about one of the factors? Or at least one of the factors.
It has to be equal to 0.
One of them has to be 0, right? That's why we're allowed to find your 0 for each case. So the first one would be x equals 0. From here, you'd have x minus 3 equals 0. And from this one, you'd have x plus 2 equals 0. And then, of course, you would solve them. So your zeros are going to be 0, 3, and negative 2. So if you were to graph that, where would you see 0, 3, and negative 2? The x-axis, right? That's where it would cross the x-axis. Okay, good. All right, so then for B, we're going to do P of x equals 2x cubed minus x squared minus 18x plus 9. So first step, do they have anything in common? Second step, is this a special pattern? Yeah, it kind of is, right? What is special about this? It's 4 terms, so you have to factor by grouping. So 4 terms means we're going to factor by grouping. Alright, so then we're going to group the first 2 together. Okay, and remember when you are using grouping, you're going to group and take out common factors. Okay, so Dennis, what's the common factor in the first set of parentheses?
X squared,
Yep, so if you took that out, what would you be left with?
2x minus 1.
Good. Okay, and Lucas, what's the common factor in the second one?
9.
Good, okay, so the common factor is going to be 9. Now this is where you have to make a decision. You want to ask yourself, okay, am I going to take out 9 or negative 9? Because you want this to match the 2x minus 1. So for this one in particular, you would take out what? Okay, negative 9. If you took out the positive, you'd want to write plus here because we're taking out the negative, you're going to write minus. Okay, so if I take out the negative, then this is going to be 2x, and then 9 divided by negative 9 is minus 1. You can only do the factor by grouping if you have the same expression in the parentheses. Okay, so you need the same expression in the parentheses to factor by grouping. And that's because what you're really doing is a version of the distributive property. Okay, so you need the same expression in parentheses to factor by grouping. So see how this is x squared times 2x minus 1? Yes, we see that? Okay, and then this would be negative 9 times 2x minus 1. Okay, so what's our common factor in both of these? Okay, so 2x minus 1, right? So what we're doing is we're taking that out. So when I take out 2x minus 1, if I take it out of this factor, I'm left with x squared. If I take 2x minus 1 out of this factor, I'm left with minus 9. And you can check and make sure you did it right, because you can think of it as the distributive property. If I took x squared and multiplied it by 2x minus 1, I'd have x squared times 2x minus 1. If I did negative 9 times 2x minus 1, I'd have negative 9 times 2x minus 1. So a lot of times students will ask me, well, where'd it go? We had 2, now we have 1. It's the same as factoring, right? When you're factoring, you're condensing the expression, and then when you multiply it out, you're expanding it. So that's what we did, okay, is we took that factor out. Okay, so now the last thing that you want to do is you want to, again, check for any greatest common factors, make sure you didn't miss any, and special patterns. Okay, so can I factor this down any further? Yeah. Hannah, what do you notice?
X squared minus 9 can be broken down into x plus 3x minus 3.
Good, so this is the difference of squares. So we can break that down into x plus 3 times x minus 3 times 2x minus 1, and that is your p of x. Okay, so this is your factored form. So again, there might be a time when a quiz or test asks you, what is it in factored form? And you'd have to write p of x equals, and then everything in factored form. Okay, and then you're going to find your zeros. Okay, when you're finding your zeros, I understand that's going to be a lot of mental math, and that's fine. I'm just writing out that you would set each one of these equal to 0 and solve. So when you solve, your zeros are going to be, what's the first one? Negative 3, and then x minus 3 would produce 3, and 2x minus 1 would produce 1/2. Okay, so those are going to be your zeros. Questions for me on those? Okay, see how some of the things we did before are coming back? We did factoring by grouping earlier. You're going to have to know how to factor different types of polynomials. Alright, for example 3, we're going to graph the polynomial and then determine how many local max and min it has. Rounded to decimal places where appropriate, so we are going to actually find the max and the min. And so I'm going to give you that equation, which is y equals x to the 4th minus 5x squared plus 4. Okay, so you can go ahead and graph it. We are going to need it to find the local max and the min. But I also want to show you how you can tell how many there are without even graphing it. Do you guys remember talking about turning points last year in Algebra 2? How many turning points does this graph have?
3.
It has 3. How do you know?
Because the 3 is 4.
Okay, and it's always what? It's always one less, right? So there are 3 turning points. It's always one less than the degree. Okay, so that means you either have 2 minima and 1 maxima, or you have 2 maxima and 1 minima. You can actually figure it out. If it's x to the 4th, what do I know about both ends of my graph? Yeah, they both have to go the same way, right? So it has to go up this way and up this way. Okay, well if it's going down, it's eventually going to have to come up somewhere, right? So you'll have 2 minima, and you'll have 1 local max. Okay, so then I just drew a little picture. Let's see what that is. Okay, so you're going to have 1 local max, maxima at, and you can write that as a point. Okay, so you have the e to the -6, which means you'd move the decimal the decimal 6 places, which means you have 5 zeros in front of that. So if you have 0.00000, that's gonna round to 0. Okay, so whenever you have the e, remember you can just put the 0. Okay, sometimes we see the decimal and then we get excited. Shawan, what was one of your minima?
-1.58 and -2.25.
Good. Alright, and then Carmen, did you find the other one?
Oh yes, -1.26.
Uh,
No, 8.
there should be something different. Yeah, I'll come over, I'll help you with it. Shauna, what'd you get?
I got, for the other,
Yes, for the other,
I got
minimum. Yep, positive
Yeah.
1.58, and then,
and,
oh, sorry, is this one, did you tell me negative?
yeah.
Okay, thanks. That should be
Yeah,
negative.
and then add.
Okay, perfect. So you should have negative 1.58, negative 2.25, and positive 1.58, and then negative 2.25. And then I'm gonna have you write your homework down, and then you and your elbow partner are going to work on your exit slip. Go ahead and I want you to look at this carefully because I'm giving you some special directions. So for 27 through 34, you do not have to sketch the graph. Okay, for 41 through 46, what I want you to do is find the end behavior of P of X. Okay, so you're just finding the end behavior of P of X. And then the rest of them, directions as followed.
So we have a minus 2x squared and a minus 3x. Or is it 2x?
It's 2x because you have to cut off 2. So to find the x would just be the
What is the formula for we want to make a box out of it. This is length and width. Wait, are you sure it's 2x?
Yeah, what she is.
I just figured it out right now. Sarah, did you get minus 2x? Minus 2x squared.
Oh no.
For the equation, what'd you get?
10 minus 10 minus I think 10 minus x times 8 minus 2 times, but 10 minus 2 above
What is the height of the box? 2 can go by x.
yeah. So technically we could do 20, it would be 20 minus 2x technically if we did it that way.
So it is
operative tray.
Is this the
Oh.
right equation?
That,
Yeah.
nope.
Is this the right equation?
Yeah, we're just putting it
Just
in.
wondering like that.
Oh, yeah, so this
So we're
is
gonna have to cut off.
okay, good. It looks like you guys are doing really well. So the formula for finding the area of a rectangle, so your area is going to equal, Caleb, what did you guys have for that?
10 minus 2x.
No, number one.
Length, yeah, length.
Okay, so yeah, so the formula for finding the area of the rectangle, you could have length times width, or you can have the area equals the base times height. Okay, and then, Blake, what'd you have for the volume? Okay, so length times width times height. So you have a piece of cardboard, it's 10 by 8. This is not drawn to scale. And you want to cut X inches from each side. So if you're cutting X inches, I'll just start with this side. If I cut X here, okay, that part's gone. So now I want to cut X from this side. Okay, so if I cut X from this side, that's gone. So now I've cut it from the top and the side. I have to cut this side. I already cut it there. So now I'll cut this here. And this would be X. I already cut that up top, so I'm going to cut here. This would be X. Okay, so basically you're cutting out these corners, right? And when you do that, look at the top. So you have 10 here, and you have X and you have X. Caleb, what'd you get for this?
For
Do you want to answer it and say Miss Ruffles' room? Yeah, 10 minus 2x?
and 8 minus 2x.
Yes.
And then that's the equation.
Okay, so 10 minus 2x, and then 8 minus 2x. Okay, so then the area of the base, if you guys want to leave it as 10 minus 2x, you can. And 8 minus 2x, you can. You could also FOIL that out. Okay, and then from there, you are trying to figure out the height. Did anybody figure out the height? Yeah, Max?
For X, it might just be X.
Yes, how do you know?
Because that's how much you take off the sides, that's how.
Yeah, so if you're taking off the X, think of it kind of like you're folding it up. So when I thought of the box, I thought of it as I'm cutting out the 4 corners. So when you're cutting out the 4 corners, when you're folding that side up, right? This is your box / tray. Okay, so you cut off X, you're gonna fold it up. Okay, now that may seem really random, trip down geometry lane, but why do we probably do that? There's going to be something on your homework where you're going to need to use that information.